All right. Well, good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. If you've been tuning in this week, you know it has been quite an intense week. We've been taking a deep dive into climate change. We've had over 20 speakers join us from around the world, scientists, explorers, photographers, filmmakers, and they're all doing the same thing. They are researching, they are documenting, they are searching for solutions to the global climate crisis that we find ourselves in now. And it has been just an incredible week, learning in the Arctic, the Antarctic, exploring our oceans, learning about the effects climate change is having on land. I can't believe it is Friday and we only have 2 events left to wrap up our week, but all the events will be up in a playlist shortly, so you can tune in with your classrooms if you missed any. And I'm really looking forward to seeing the questions that come in today. I can see we have an active chat on YouTube, so a big shout out to those who are tuning in live with us. Get your questions ready. We're looking forward to taking your questions. Looks like Tucson, Arizona, Flemington, New Jersey, 4th grade class. We have another class hanging out with us in Winnipeg, Manitoba. So great to see everybody saying hi, and we're looking forward to your questions coming in shortly. All right. Well, I am thrilled to have Melinda Webster joining us today. She's a polar scientist with the University of Alaska Fairbanks. Her work uses a combination of satellite, airborne, field, and model data to study the frozen oceans of the Arctic and Antarctic environments. She's been involved in several polar expeditions, including recently aboard the Mosaic expedition, which was the largest ever expedition undertaken in the Arctic. It lasted for a year. So she's traveled by aircraft, by ship, by snowmobile to collect measurement of sea ice so we can better understand what's happening to it, and of course its role in the greater Earth system. So she grew up in a small town of Oklahoma. Being frozen in the middle of the Arctic Ocean probably wasn't too different than what she was used to. So I'm going to bring her in with us now. Hello, Melinda. How are you doing today?
Hey, doing really well. Thanks for having me.
All right. Well, you're in a much, warmer location right now in Arizona, so maybe not too far away from our classroom joining us in Tucson. And I do want to shout out, looks like a grade 6 class in Thunder Bay, Ontario is joining us as well. So keep saying hi, classrooms. We'd love to see you joining us. Melinda, I'm going to let you take it away for a little bit. We're so excited to get a little bit deeper into your work.
Okay, thanks a lot, Joe. Here we go. I'm going to share my screen and hopefully you can see everything. Let's see. All right, how does that look, Joe?
Looking good. We're ready.
Okay, so thanks a lot for having me today. I wanted to share what my life is like as a polar scientist. As Joe said, I'm at the University of Alaska Fairbanks, but I spend a lot of time between there and Seattle, Washington as well. So I am talking about one part of the cryosphere, and this part is the frozen part of the ocean, or sea ice. I am very, very passionate about studying sea ice. I think it is super cool, and I want to share with you today why it's so cool. And let's go over why it's so important for our climate. So one reason is it is a powerful reflector. It's very white, reflective. It's reflecting the majority of sunlight back into space. And this is really important because it helps keep our climate cool. It's kind of like the thermostat of our planet. And so without sea ice, our planet would warm and our climate would get really, really, really warm. And you can see this in satellite measurements. So here is a measurement of temperature around the globe. And you notice that at the poles, it's a lot colder, right? That's because there's sea ice, and it's also because it's at a skewed angle with in relation to the sun. So these areas are really where our Earth stays very, very cold and heat is lost to space. So without it, we get too warm. With it, we're doing just fine. And sea ice is also really important because it helps power ocean circulation. So sea ice, it helps cool the seawater. And when the seawater starts to form, there's a lot of salt that's left behind in the ocean. And when water gets cold and salty, it gets heavy, it gets denser. And this dense water will sink, and that drives this circulation of slow-moving currents in the ocean. And that's really important because ocean circulation helps redistribute the heat around the Earth. Now, there's also one really, really cool thing about sea ice, and maybe you can see a clue here of what that is. you might see this blob moving around. What's special about sea ice is that it has salt in it. And salt is really cool because it creates these little channels full of really, really salty liquid stuff. And there are actually organisms that can live in these little channels full of salty solution. And in fact, on the lower left is an example of a diatom. This is a type of phytoplankton, so they're like the plants of the ocean. But these are really important because they create the foundation of the food web in polar oceans. And another cool thing about this is that these environments are very extreme and very, very cold and very, very salty. And this may give us clues to where life might be on other planets and moons. So as you can see, sea ice is awesome, but how did I end up being a sea ice scientist? It definitely wasn't a straight path. As Joe said, I'm from a very small town in Oklahoma, a small farming town. And I went to school after, I went to university after graduating high school, and I didn't know what I wanted to do. I got overwhelmed, so I stopped going to university. And I started doing a bunch of different jobs, and I got one in Glacier Bay National Park as a volunteer. And I was able to go out with scientists and help them with their field work. And there I learned that being in the outdoors is awesome. Having all these really, curious questions, driving questions, and having the ability to answer them was really, really fun. And the ice environment was just beautiful. And I wanted to really get back out there and do something like that. So I wanted to get involved in polar science. So I did some research and I looked around at different colleges to see which were doing a lot in polar science. And I found the University of Washington. And after getting my degrees there, everything was working well, and I was still doing science, and I still wanted to stay in science because it was really fun, so I became a scientist. And as you can see on the lower right, my path was bouncing all over the place. So while I was at school at the University of Washington, I went to a bunch of talks that were really interesting. And one was given by this guy, Ignatius Rigger, and he was showing this animation, and you can see all the ice moving around and these red dots. And I was just fascinated because this shows how dynamic the sea ice cover is. It's moving with the winds and the ocean currents. It grows out in the winter. It shrinks back with melt in the summer. And I was just fascinated because here is somebody who's going out and deploying these little red dots. These are actually buoys that they've put out on the ice. And they're using that combined with satellite measurements. So knowing where the ice is, these different shades of blue and white, and models to get the age of the ice, using all these different tools to study how sea ice is changing and how it's moving on seasonal and annual timescales. So every season and every year. And I want to do that. I want to get involved. So I went up to Ignatius after his talk and asked, hey, do you need help with anything? I know nothing about sea ice. And he said, sure. And he became my advisor for my bachelor's, master's, and PhD, and I graduated. So he introduced me into the world of sea ice. And from graduating, I got a job at NASA's Goddard Space Flight Center, which was really, really cool because I got to get a much broader perspective of how important sea ice is for our climate. And what's really awesome about NASA is they monitor the cryosphere using satellites and aircraft. So it gives you a bird's eye view of what's happening. So you can really see this rhythm of the Arctic sea ice cover and the Antarctic sea ice cover of how it shrinks back with summer melt and grows out with winter. Having that idea of how the sea ice is changing on these year-to-year timescales and seeing how it's changing with climate change, how we're losing sea ice, was really valuable. From NASA, I got offered a dream job at the University of Alaska Fairbanks, and that was to be a sea ice scientist and an educator. And everyone has a very different view of what scientists actually do. You could ask my mom, you could ask my friends, you could ask my boss, and I think you get very different answers. So what do I actually do as a polar scientist? Well, I actually spend a lot of time being creative, doing a lot of writing, a lot of reading. I'm writing proposals, I'm writing papers, I'm corresponding a lot with my colleagues and friends. We're analyzing a lot of data, so using a lot of math and science. But hey, I'm not good at everything. Like, for instance, math is my weak point, so I can go to my colleagues and friends and get help. It's really cool because being in polar science, and probably any field in science, is a lot about teamwork. And then another good section of my job is really being social. I'm an introvert, but it's actually a very social job because you work with a team. It's really important to be a team player. You reach out to the community like this, and you also network a lot. So you meet new people and you try to figure out how you can work together to tackle these climate change problems, which is really cool and fun. Now, I can't overemphasize how important it is to be a good team player and teamwork. And I think we're really, really lucky in the sea ice community because it's like working with a bunch of friends, and they're all so kind and so willing to help one another and so knowledgeable about different pieces of the climate system and the sea ice system that it's really awesome to be working with this group. And this is just an example of some of the things we've done working out in the field and things like that. Now, for my work, I'm really interested about this transformation of the Arctic sea ice cover as it goes from a cold, snowy wintertime state to something that's completely covered in melt ponds and eventually either melts completely or freezes back up in the autumn season. And I try to use every tool in the toolkit. So I'm using ground observations, I'm using measurements from aircraft and from satellites, and I also use output from climate models. So climate models are really important if we want to understand how things affect one another and how things may change in the future. Two things that I really like about sea ice is its snow cover and the melt ponds on it. These are two different things, but they're closely related. And there's a pretty common connection of why they're so important, and that is they affect the surface albedo, or how reflective the surface is. I was talking about sea ice being really, really reflective and being really important for regulating our climate. Well, snow is the most reflective natural surface on Earth. And as soon as snow melts, it turns into a melt pond, and melt ponds are darker. And so if they're darker, they're absorbing more sunlight and they warm up and they melt the ice faster. So how snow is distributed and where the melt ponds are and how quickly snow changes to melt ponds is really important to understand for albedo feedbacks and the reflectivity feedbacks that I spoke about earlier. Now, one of the fun things about melt ponds and snow is that they're really complex, and so I'm really busy trying to figure out what they're doing because they change spatially and also in time. So here's an example on the left of a melt pond that's really, really big, and then the next day it's completely drained. So these melt ponds can drain and then they can reform and they can change in location, and all of this behavior is affected by the sea ice physical properties. So how much salt there is, how warm the ice is, even the topography of how rough the surface is, that all affects melt pond behavior. And that stuff I just really enjoy learning about and trying to figure out. Now, snow is also complex, and snow is really cool because it's really closely related to what's happening with the atmosphere. So how much snow there is, how much wind there is, and also the sea ice conditions. So is the sea ice really rough or is it really smooth? And that changes how snow is blown around and redistributed. And guess what? And how snow is distributed affects where melt ponds grow. So there is a strong relationship there. These are all tightly related, tightly coupled, and that's what I really enjoy studying. So I've been spending a lot of my time this year trying to figure out how snow and melt ponds behave over time. And I had this really cool opportunity to get involved in a mosaic expedition. And I would go out on a near daily basis measuring snow, and you can see me in the middle melt ponds, and looking at how these changed over time. And this, again, is really important because it changes how reflective the sea ice surface is. But it's not just reflectivity that makes snow and melt ponds important, and I want to show this example. So this is a gigantic melt pond. It was like a lake, and I went swimming in it to take all these depth measurements that you can see on the left. So this is before it drained and after it drained. So the top right figure is me swimming around, and the bottom right figure is the same melt pond, but after it drained, and it had a huge difference in the amount of meltwater within it, right? Well, when a melt pond drains, it goes into the ocean, and this has a big impact on the structure of the upper ocean. So how fresh it is or how salty it is. And melt ponds are putting a lot of fresh water into the ocean when they drain. So this can enhance the stratification of the ocean. So it creates all these different layers, and these layers can be kind of like a barrier to different types of phytoplankton, so those plants in the water and different organisms. So it can change the distribution of who's living up high and who's living down lower in the water column. And maybe you can see that in this video, that green layer on the bottom and this relatively clear blue layer on top. That's the difference between a freshwater layer and the salty seawater below. And I thought that was really cool. Okay, so after we go out in the field, we collect, we have all these wonderful data sets that we've collected, and we're really happy about them, but it doesn't stop there. Once we get home, that's when we get to make the real discoveries. It's like the big reveal of what did we collect, what did we learn, and we piece all these things together to tell a story. So like each paper is like a story of what we learned, what we're understanding, and how we're improving our understanding of how the climate system works. And that's what I really enjoy too, as being a polar scientist. Okay, so that's really the end of my talk. I just want to say that polar science is awesome. There's a lot of opportunities to do cross-cutting topics. So if you want to know how the atmosphere, ice, ocean, and ecosystem interact, sea ice is a wonderful place to do that with. We get to use all sorts of cool things to study climate science and sea ice in particular. So using field observations, aircraft and satellite measurements, and also climate models. And the stuff that we're learning is really, really useful, not just for understanding how the climate system works, but also how habitats for different animals change, how easy or difficult it is to travel through the Arctic by ship, and also for people living in the Arctic that use sea ice for subsistence hunting and transportation. So there's a lot of really cool uses outside of climate science for studying polar science. Okay, that's it. So thanks a lot for listening, and I'd be happy to take any questions at this stage. Thank you.
All right. Awesome, Melinda. Thank you so much for sharing such a great presentation today. And yeah, I mean, your day job can take you to some pretty amazing locations on the planet. Absolutely beautiful locations, but they're changing so quickly. It must be something to see. And those melt ponds, I mean, I'm glad to see that you were swimming in one, because the water looks beautiful blue and it looks super refreshing. So I don't know if I'd be able to resist maybe a quick, short polar bear dip in one of those.
People did. People do that.
Doesn't surprise me at all. All right. Well, I can already see questions coming in via the chat. So use that chat sidebar and send us in some questions. Here come a few more. Let me start with one, just touching on a talk we did yesterday. We talked to Liana Nixon, who was on the Mosaic, and she took a lot of media, a lot of pictures, a lot of video during her time. And she said during her time on the boat, it was like polar bear city. There were so many polar bear sightings. How was it for you? Did you get lucky? Did you get to see lots of polar bears out on the sea ice?
Yes, so Liana and I were on the ship at the same time, and I think we had a polar bear visiting, at least one visiting every day for a week. It was so frequent, and honestly, it was super cool. But when that would happen, we would go back on the ship. We're not going to scare them off because it's their home that we're visiting, right? And it was just really cool to take a moment and watch them in their natural environment. Very cool.
All right. Well, let's start with a couple of questions here. All right. So Mrs. Danika's class, they are wondering, does the weather conditions make your job difficult?
Yeah, sometimes it really does. So a good example is in the springtime, it's really, really cold. So if you get a little bit of wind, it actually makes it quite difficult to work in that cold environment because plastic and metal will snap. It's so cold. You have to be really careful about not getting frostbite and making sure everyone's warm enough. So wind can be a really big factor in extreme cold temperatures. Fog can be a bit difficult because, like we mentioned before, there were a lot of polar bear visits during the Mosaic expedition. And you want to have a good lookout so a polar bear doesn't get too close. But if it is so foggy that you can't see well, it's better to stay on the ship and not wander out when you don't have good visibility. And also there can be blizzards and whiteout conditions. And again, we don't go out in those conditions. We really err on the outside is safety, so nobody gets put in a bad place.
Yeah, absolutely. I mean, that's probably one of the biggest logistical things about an expedition is, planning to make sure everybody's safe. And yeah, absolutely. No sense taking risks. Yeah. All right. Let's see. Okay. So this is from Mrs. Lauderdale's class. And they're wondering, they saw the water and they saw some of the really small life in the sea ice. They're wondering if below the sea ice or maybe even coming up into those melt ponds, are there any fish species?
Yeah, so I'm not a biologist, but I do know one species that we saw, and that's polar cod. And what's really cool about those, we saw them in cracks in the ice. So the ice can create like very, very narrow cracks, like that big, right? And the polar cod would be hanging out in there, and they'd be eating algae and just hanging out. And sometimes there would be holes in melt ponds, and we'd see polar cod going into the melt ponds through those holes. So yeah, there was definitely fish, and they were very small fish.
All right, great questions coming in via the chat here. So this is Clutchy's group are joining us. They're our group in Thunder Bay, and they are wondering, this is Luca. Luca wants to know, did anybody fall through the sea ice?
Yes, several people did, and I fell through the ice too, but guess what? I don't know if you could tell in that melt pond figure, but I was wearing an orange suit. It's called a survival suit. And you zip it all the way up and you have your hood on, and it's watertight, meaning the water can't get inside. So you're actually dry as you go into the water, and you're safe. And it provides a lot of buoyancy, so you're floating on top as you go in. And that's a really, really important thing to have in the field when you're surveying all these melt ponds, or if you're walking on really thin ice that's just newly refrozen, and maybe it has snow on top, but you can't tell how thin the ice actually is. Those safety suits or those survival suits are really helpful.
All right, fair enough. Another case of being prepared.
Yeah.
Okay. Here's another one here. This is from Alex. Alex is in grade 6. And Alex would like to know, what was it that made you want to become a polar scientist?
Alex, that's a really good question. I think it was a combination of things. So I really like getting outside. I love getting outside, and the field work was really exciting to me. But also, I'm really curious about things. I ask a lot of questions, and in science, it's kind of like you're being paid to be curious. You're being paid to ask questions and try to find the answers to those questions. So I feel really, really lucky because I'm getting paid to do things that just are a lot of fun to me. Being curious, getting outside, and I also get to work with really nice and awesome people. So I think that curiosity and the outdoor element is really what hooked me into polar science.
All right. Mrs. Kalum's group, they're joining us in Winnipeg, Manitoba. First of all, they're saying great presentation, Melinda.
Oh,
and they're curious. So Mosaic was long. That was a year-long expedition. Sounds like you were out for somewhere in the neighborhood of 6 months or so.
Yep.
Yeah. What is a typical expedition? What's the length of a typical expedition?
Well, that's a really good question. They vary quite a bit in time. So an airborne mission can be a few days, a few weeks, maybe a month even. Going on an icebreaker can be anywhere from a couple of weeks to a month and a half or a few months. So they're often much shorter than the Mosaic expedition. Mosaic was really special. It's rare to have a year-long drift experiment. In fact, the last one that lasted a year was more than 20 years ago. And I think there hasn't been many since then. But yeah, it's extremely rare to have something that lasts a year. Normally it's about a month or two.
Yeah, well, incredible opportunity to collect data over, an extended period of time. And I think a lot of it is to get a baseline so that when you coming back in future expeditions, you have some good data to compare to.
Oh, absolutely. Yeah. And with things changing so quickly, it's really nice to have that older data sets to make these comparisons with.
All right. Let's see. So many good questions. This one here. from Mrs. DeLeon's group, and they're wondering about a couple questions about your gear. So they're wondering, do you carry a lot of gear on the ice with you? And then can you tell us about a couple tools you use?
Sure. So I bring all sorts of different gear depending on what I'm doing. If I'm working in the springtime when it's really cold or in the winter when it's really cold, I'll have a backpack just full of clothes, extra layers. And I'll also bring a lot of snacks. I know that sounds kind of silly, but it's really good to bring chocolate and things like that because it helps keep you warm. Bring a thermos full of hot chocolate or hot tea or something like that. Those little things actually make a big difference. For instruments, I try to bring spare batteries. I try to bring a field notebook. So if I see anything really weird or really cool, I can always write it down. I try to bring a little camera because a picture is often worth a million words because that just brings so much insight into a single measurement. You may get a number from an instrument, but having a picture with it is really, really nice. And also, depending on the mode of transportation, that changes what you can bring. If I'm driving a snow machine out, I can put a lot of gear on the snow machine and extra safety equipment and things like that. If I'm on foot, then I really can only carry what I'm physically able to carry. I can't bring every instrument into the field. I'll need a team with me. So it kind of depends on how you're traveling over the ice.
All right. Okay, we've got a student here who's clearly thinking about their future. We've got Kate joining us. Kate's in grade 5, and she wants to know if you recommend getting a PhD.
Oh, well, that really depends on what you want to do. I think you can do a lot of cool stuff in polar science with or without a PhD. It really depends on if you want to go into a research route or be a teacher, or maybe you want to be a field tech and work and repair all sorts of instruments, or maybe you want to be involved in developing code for analyzing data. So I think you don't have to get a PhD to get involved in polar science. But if you want to say go the research route or go the route of being a professor, then a PhD does help. So yeah, you have lots of options there.
Okay. Let's see. Okay, here's an interesting question about, this is Mrs. Lauderdale's group. They're wondering about pancake ice. What causes pancake ice to form?
Oh, pancake ice is so cool. So when you have ice that's just starting to form and you have waves or winds, that breaks the ice and creates these little circular discs, and they bump against one another and they'll grind against one another, and that builds up these little edges on the little circular pancake flows. So it's a mixture of dynamics, like small scale motion from wind and waves that break up the ice, and they bump around and create those circular patterns of these little flows. And they're really cool looking.
All right, very cool. Marwan wants to know, what makes your job hard? Is there something about your job that's difficult?
Yeah, I mean, I think with any job, there are some challenges. For one, being in the field for a long time, it is tiring. I was pretty sleep deprived, but it's hard because you're really excited at the same time too. But a field campaign can be exhausting. So that's just on the physical side of things, tiring. But then when you get back to the office and you're looking through data, I think it's really important to be okay with failure, because science is all about failure, and you work through obstacles and you get over them, but you'll try all these different things to try to get an answer, right? I was talking about being curious and asking questions. That also goes hand in hand with hypotheses. So why does it do this? Well, I think it could be due to A, B, or C. And say none of those work, and that doesn't feel good. But at the end of the day, you're still learning something through these failures. And I think that's the hard part, is learning that failure is actually a good thing. That's where you learn the most.
Yeah, I think that's an excellent point, and so important for students to be thinking about, is there's beauty in a failure. You learn from your mistakes, you attack it from a different angle. And, scientists and explorers that we've hosted say the same thing. You go out in the field with 10 questions and come back with 100. That's just
exactly. Yeah.
Very cool. Okay, back to Winnipeg. Winnipeg, Manitoba would like to know, is there something that makes you hopeful about climate change? We hear a lot of news about the way things are changing. We see changing weather in different locations, weather becoming more severe. Is there something that gives you some inspiration or hope when you think about it?
Absolutely. Yeah. I think humans are resilient, and I think there's a lot that we can do when we band together and we tackle these climate change issues. And I guess I can't understate that or overstate that enough, is that humans are really, really resilient and really smart. And I think if we just work together, we can get through some of these major climate issues. So I'm very hopeful in that respect.
All right. So Mina is joining us, and Mina would like to know, we saw you in your suit and in the water. Are you hot in that suit? Do you feel really warm?
Yeah, it depends on the day. So in the summer, it's like in the 30s Fahrenheit or a little over 0 Celsius, and it can be warm moving in that suit because there's no breathability. But on the other hand, as things were starting to freeze up and ice was growing again, that suit was pretty cold because there's no insulation in it. So I had to wear a lot of layers underneath. So it's kind of like wearing a shell outside that doesn't let you breathe well or your body breathe well. It's not the most comfortable thing.
Fair enough. I love this question. This is from Miss Clutchy's group. Katie would like to know, before you go on an expedition, do you practice anything? Do you practice using any of the gear you're going to use or any of the steps you have to do?
Oh, yeah, big time. I will often lay out everything that I need and make lists and remake lists and look at old lists from previous field campaigns to make sure I have everything for a certain instrument or all my clothing right and things like that. And then when I get into the field, before I'll actually go out and take measurements, I'm usually working with a team and we'll discuss a plan, we'll test the equipment, make sure everything's working. And I think there's a lot of redundancy involved, like we do things more than once to make sure things are working. And guess what? A lot of things break and it requires a lot of repairs and some of those challenges. But it's really important just to test things and to talk through things to make sure things will be efficient and you're getting good data at the end of the day.
All right. So many great questions. The students are definitely curious today about the work that you do. So we'll work in at least another one or two more. This is from Mrs. DeLeon's group, and Connor is wondering, have you ever been scared on an expedition? Is there ever a time in the field you've been nervous or, yeah?
Yeah, I think maybe when I've been scared, it was not so much being scared, but surprised when I fell through the ice because I really didn't expect that. And when I was in the water, it's like, okay, I'll just roll out. And so, you just crawl out and it's fine. You can naturally roll out of the water onto the ice. But I think maybe the scariest bit as I fell in was, will the instruments be okay? Because the instruments are expensive. You often don't have a double or a replacement when you're in the field. So that's the scary part. It's like, oh gosh, if I just break the instrument, what do we do as a replacement? What do we do as a backup? So it's not scary for my life. It's just scary for our goals for the field program.
Yeah, absolutely. Resupplies would not be easy.
Nope.
Okay, so let's wrap up with two more questions here. We talked about something that makes your job difficult. I have a feeling I know the answer to this one from Miss Lauderdale's crew. What's the favorite part of your job?
Oh gosh. There's so many good things about it. I don't have a single favorite, but here are some of the things that I really love. Being out in the environment is incredible. I don't know how to describe it. It's like being on a different planet. It's just so beautiful and so remote. I think that's a really rewarding experience, and I'm really grateful to have that experience. So that's one thing that I love. A second thing is the people I get to work with. They are all rock stars. They are just so fun. They're so positive and they're so smart. I'm constantly learning something new from them. So it's kind of like, I don't know, there's not a chance to get bored. You're always doing something. You're always learning and laughing. It's just fantastic. And I guess the last thing is getting to engage with people like you, like just talking about why this is such a cool thing. as my life, and hearing that other people might actually get excited about it too, that's pretty rewarding. The fact that you guys are still listening and asking questions is awesome.
All right. Very, very cool. So you mentioned, the crew on board, and a lot of fun to be with, your different crewmates. And, I bet it ranges from, navigators to the scientists, to the engineers, to the people who are, preparing the meals. Like, there's so many jobs on board of a ship, and everybody plays a really important role. I'm wondering, in your spare time, are there any games or fun things that you guys like to do together?
Yeah, there are a lot of fun things that we used to do. So we'll play music and sing along. We'll have art nights. It's kind of like living in a little city. Like, you make fun happen, and you just have these, like, we'll have a quiz night. It's just stuff that you would do in everyday life with your friends. We just try to bring some of that normal life into our work.
All right. And this might be impossible to choose as we're wrapping up, but between the North or the South, is there a place you prefer to work, the Arctic or the Antarctic?
Oh, you can't ask that question. They're both amazing.
Yeah.
They're both wonderful. I would not be able to choose between them.
All right. Fair enough. Fair enough. I do want to slip in this question for Justin, because it looks like he wants an answer. Snowmobile. Do you get to use those sometimes, and are they tricky?
I use them a lot, and once you get the hang of it, they're not too tricky. There are little tricks that you can do to make sure that you don't tip. There are tricks you can do when you get stuck, how to dig it out quickly. Especially if you're a small person like me, these tricks are really helpful. But yeah, they're fun, and sometimes they go a little too fast.
All right, fair enough. Well, Melinda, I want to start off by thanking all the classrooms tuning in live via YouTube right now, whether you're in Arizona, New Jersey, different places in Ontario, Manitoba. Thank you for all of these great questions, really great Q&A in the chat today. A shout out to the classrooms who will be tuning in next week. Thanks for joining us and checking out the event. And then Melinda, thank you. Thank you for joining us. Thank you for sharing the work that you're doing. Just a great presentation, and lots of great advice for students tuning in today.
Cool. Hey, thank you guys for being interested in this and getting excited with me about it. That's pretty awesome.
All right. Well, we have one more event coming up with Don. Don, actually, Melinda, you recommended Don to me. He's going to be our final event. He's going to talk a little bit more about sea ice and why it's so important, how it plays that reflective role. So do tune in if you can. We'll be going live on the channel in about 20 minutes. So thanks, everyone, and have an incredible weekend.
Thank you.